Thank you very much. So this is a talk actually about 3 different radars. I'll turn my clicker on before it'll work. So just out of curiosity, how many people here have seen a ThoughtWorks technology radar? This is a document we produce twice a year. It's a white paper from ThoughtWorks. That's the first one I'm going to talk about and give you a little bit of origin of where this came from. And that is going to be the basis for the other 2 radars that I talk about. And the first other one that I want to talk about is one that you build for yourself as a developer, as a career management tool, as a way to figure out what should I be spending my spare time learning that's going to best better my career. And then the other radar I'll talk about is probably the most unexpected one that came out of this exercise, which is building one for your company by way of creating a feedback loop where one is probably missing now. So first I want to talk just a bit about the ThoughtWorks Technology Radar. ThoughtWorks is the company I work for. We're an international consultancy with offices in 12 countries now. And twice a year we produce this document, a technology radar. This is the one from October 2012. There will be a new one come out on May 21st. And you are the first people outside of ThoughtWorks to know that, because we just met face-to-face about 4 weeks ago, and I just found out today the next one's going to be published on the 21st. So May 21st, if you go to thoughtworks.com/radar, you'll get the latest version of this document. And the first page is basically who we are and some themes that we've pointed out and the group of people who put this thing together. But this is the main visualization. It's a radar view split into 4 quadrants for techniques, tools, platforms, and languages and frameworks. And we have 4 rings on here as to what we think about what that technology is doing out in the world right now. And then the rest of the pages, actually let me, take each one of those quadrants and split them out separately and write a couple sentences about each technology. We don't write 2 sentences about every technology, but something that we think requires a little more explanation as to why it's here versus here, or why it's included, or one of its competitors is not included. So we have these little write-ups, and this usually is a couple of pages per quadrant, so that's the one for one quadrant. We do that for all 4 of the quadrants, and then the last page is who we are and what we do. So this is the main visualization that I'm talking about here, is this kind of radar visualization. It's probably worth giving a little bit of history behind this. Rebecca Parsons is the Chief Technology Officer at ThoughtWorks, and she has the normal job of someone who works for a consultancy of more than 2,000 people. But she has additional responsibilities as well, because ThoughtWorks as a company tries to be very, very proactive on our technology choices. We try to advise our clients for technologies we think are suitable for their problems and guide them away from things that we don't think are suitable. So as a good example, we were very early proponents for using Ruby on Rails in the enterprise, because we looked at the technical merits of Rails and realized there were some really nice features there that some of our clients were building applications that could benefit from that. And we understood the benefits and the shortcomings and were confident in our ability to make that assessment. And so one of Rebecca's jobs is kind of the overarching technology direction of ThoughtWorks as a company, and the things that we want to emphasize as a company and the things that we don't want to spend as much time on. But of course, no one person can probably know the breadth and depth of technology all over the world, and so Rebecca has created an advisory group called the Technology Advisory Board, or colloquially known as the TAB. And this is a group that advises her on her technology decisions, and we make decisions about things like how do we retain senior people and hire people, and we have coding exercises that we give to our candidates, so the Technology Advisory Board comes up with and vets those coding exercises, so a lot of activities like that. This is actually a virtual body that meets every 2 weeks by a hideously timed international phone call. I happened to miss the phone call this week because it happened at 2:30 a.m. Bangalore time, and I didn't want to get up for it. So depending on where you are in the world, we actually shuffle the time so that different people from different parts of the world can make sure and get on it. But we meet face-to-face twice a year, and have since the very early days of the TAB. And we have a very full agenda when we meet, but we also are all technologists at heart, and we love to get together and talk about technology. And so it always became kind of this partial geek fest where we were showing off the coolest technology that we'd seen lately. And over time, we started formalizing that discussion more. We started sharing it internally with people at ThoughtWorks, and then we started sharing it with some of our clients. And at some point we decided if there was an interest in the world in it, we should start publishing it in a white paper, and so we did. We're actually quite surprised at how popular it has become as a white paper, and I think there are two reasons for that. One is that it is a metaphor for something that a metaphor didn't exist for before. I don't think it's a perfect metaphor for it, but it's a metaphor. And sometimes you need some sort of scaffolding to hang ideas off of before you can really take and build the next great metaphor. So while I don't think it's perfect, I think it's a pretty useful way to capture this information in one kind of visualization. The other reason I think it's kind of popular is that as a company, we're very opinionated, so we're not afraid to say bad things about technologies. Normal consulting companies, there are adults in the company that prevent the technologists from publicly saying bad things about technologies because that limits the amount of projects you can work on. But we don't like to work on projects with crappy technology. So that's actually okay with us, that we actually put out in the world that we don't like things. So it's very opinionated, and it tries to be as honest and as objective as we can. And I think people gravitate toward that. And this metaphor has gone kind of viral. So back at QCon London last year, they actually put together this trending thing where people at the conference could vote on what they think trends and technologies are, and they basically borrowed our radar metaphor pretty much directly. So this is becoming a pretty popular metaphor out in the world. It's important, though, to understand what our radar is, because the one I'm going to suggest that you create is slightly different. It's the same metaphor, but to slightly different purpose. For us, the technology radar is a snapshot in time by opinionated technologists. That's all it is. This is not an official policy statement from ThoughtWorks Incorporated. Way beyond that. It's nothing like that. So this is not meant to be comprehensive. We do not suspect that we've touched every technology in the world. These are only technologies that we have experience about, that we feel qualified to make comments about. So there are giant gaping holes in our radar for places that we never even go. It's not a technology life cycle assessment tool. Some people want it to be that, but it's not that either. It's a snapshot. And I'll actually talk about how things age off of our radar. But there's a side effect here of many, many things that we truly love at ThoughtWorks don't show up on our radar because it's a snapshot in time. If those things haven't done anything interesting recently, then they're not going to get snapshotted. This is also not a strategic document from a ThoughtWorks standpoint. It is mostly just opinions by technologists. So this is not something that ThoughtWorks is trying to move the industry for some agenda. So let's talk a bit about the mechanics and what all the pieces mean on this radar thing and how we put this thing together. So the radar is actually in 4 quadrants. I'll talk about the names of those quadrants in a second. And so for each one of those quadrants, we go through an exercise. And it looks like this. We get together. Is this the next slide? We get together and basically brainstorm. We get together and, I went too fast, what I thought. So for each one of these quadrants, this is the one I was trying to get. We brainstorm for about 20 minutes using sticky notes. So everybody has a pad of sticky notes in front of them. So we say, okay, we're going to talk about the things that should be in the languages quadrant on the radar. So everybody write your favorite choices down on sticky notes and go stick them on a whiteboard. We have the 4 bands, the 4 rings of the radar stretched out as bands. And people write down their favorite technologies and stick them on the whiteboard. And then we go through each one of them one at a time. We clump all the like ones together. So, on a current radar, a really popular tool would be something like language would be CoffeeScript. So there'd be several CoffeeScript stickers, and we bunch those together. And we go through as a group and talk about each one of those technologies. Should it be on the radar? Should it not be? Where should it go, et cetera? We capture that information, and then we do those write-ups for each one of those little blips, a couple of sentences each. We decide later which ones go on the actual document or not, but we have the context for each one of those choices. And that little bit of context for each choice is important for later. We share and make sure these all work, and then we start brainstorming for the next quadrant that we're going to work on. So here are actually some pictures from some of our radar sessions. There's some sticky notes on whiteboards and exercises like that. So let's talk for a second about what the rings on our radar mean. The outermost ring on our radar is called hold. Any technology that shows up here, we're meaning to say proceed with caution. So we're pragmatists. We realize that if you're using some sort of technology, you can't just stop using it overnight. You need to have some sort of transition. And so we don't have an avoid category. This is as strongly negative as we get. And this was actually one of Rebecca's decisions early on that we've come to view as being very deep in wisdom. Because if you have an avoid category, this radar becomes very backwards looking at all the bad technology choices we made in the past. And that's not the purpose of this radar. The purpose of this radar is to be always forward looking about future choices, not about past choices. So the most negative we say about anything is put it on hold, and all that means is you shouldn't start anything new in it. Keep your existing investment in that technology, just don't start new stuff in it. And almost always when we put something in hold, we have a good reason and we provide an alternative for that. We almost never put things in hold just out of spite. Almost. The next ring in is assess. And something that shows up in assess means that it looks promising from what we've been able to learn about it by casual observation, and it's now probably worth spending a little more time understanding what this thing does. The next ring in from there is called trial. That means that we've done an assessment and we think it's worth pursuing. It has some promise for some problem we're trying to solve. It's important to understand how to build up this capability because we think our competitors are probably going to be able to build up this capability. Something like NoSQL or big data would be a technique or a tool that you might be thinking about building up that capability because it has a strategic advantage for you as an organization. You may try this on a low-risk project now just to see exactly how it plays out on your project. We wanted to come up with a criteria for when we move something from assess to trial. And the criteria we have for this is we only move it to trial if we've used it on a real project to solve a real problem somewhere. We are firm believers that you don't really understand technology until you've used it to solve real problems, and we never move anything to trial unless we've used it on a real project. And we are very steadfast about that. There are camps within ThoughtWorks. Some of us dearly love Clojure, and others dearly love Scala. And for a while they were together in the radar, but we got a Scala project before we got a Clojure project, so it was able to creep forward into trial. And Scala was lagging, or Clojure was lagging for a while, but we've since gotten a Clojure project, so it's pulled up even again. Even things that we think have enormous engineering potential and really, truly, dearly love, we don't believe that you understand it until you've used it to solve real problems, and so we're very adamant about that. The innermost circle is adopt. And this basically means that the industry has finished trial on whatever this thing is, and we feel pretty strongly that you should probably be using this, and we've found proper ways to use this. We have best patterns, best practices around this. It's well understood as a way to take advantage of this capability from a technological standpoint. We also wanted a criteria here as to when we will call something adopt and how we would differentiate that from trial. And Mike Mason, who's the head of technology for North America and also a TAB member, came up with a criteria that we're calling Mason's Razor that we like a lot. And it is, if you're using some sort of ridiculously flawed technology, like, for example, ClearCase, we won't say anything bad to you while we're at work, but when we go to the pub later for drinks, we'll make fun of you for using such inappropriate technology. So that's Mason's Razor. I'll make fun of you for the pub if you're not using something in adopt and you're using something horrible and broken instead. So let's talk for a second about the shapes. Now, on the main radar, the big circle, we only really have two shapes. We have triangles and circles. And this is a PDF white paper right now. There's no interactivity. And we're working on that. There are actually quite a few challenges of producing something that's white paper and interactive and make them both look really good. I'll show you the tool that we're going to use to make this interactive. Currently, though, we just have like one radar's history, and I'll show you how that manifests. But on the blown out individual quadrant pages, we have a lot more shapes, and those are the ones I'm going to talk about here. So anything that shows up as a triangle means that it is new on this radar. And something that shows up as a circle means that it's been here at least one radar before. The little triangle, the little shadow, shows the position on the last radar, and the little vector shows how it moved from the last radar. So by looking at cross-mobile platforms on this is a 2010 radar, it says that it's moved inward from a assess just a little bit. It was Neal on this radar, and it's moved in. It's still in assess. It's crept a little closer toward trial on this one. We also have these little things. It's a star that has burst into little blips. These are things that were a category of tools. This used to be distributed version control systems that we were tracking as a single technology. But then we realized we wanted to track Git and Mercurial separately, both of which are distributed version control systems. And so it burst, and these are now individual blips on our radar. Then finally, when things make it to adopt, and they've been there for a little while, they fade away and they age out. This is what we call passing through the center. And this actually gets toward the fact of how this is not a technology assessment tool. So if you look at the way technologies usually appear on our radar, is they pop up and assess first, and they gradually move their way into adopt until they become obvious no-brainers and everybody should be using them. And we have a rule that if a blip hasn't moved in 2 radars, then it automatically fades away. That technology won't show up on our radar again until maybe 10 years later when something way better has come out and it might pop up and hold again. But notice there's a huge chunk of time where even beloved technologies don't show up. So if you look at our radar now, GitHub is not on there. We love GitHub. But that blip faded off a couple of years ago, and we're not constantly going to re-blip things we love because it would just be one solid blue mass, and it's not that useful to anybody anymore. So it's not a life cycle assessment tool. It's very much a snapshot in time. So here are our aging rules. Blips age off the radar after 2 radars with no movement, unless we specifically want to re-blip them for a reason. There are a few times where we want to make a statement about something, like by blipping it. So for example, enterprise service buses is probably on hold on every single radar we've done because we think that's a terrible idea and we have much better alternatives. So we keep re-blipping that one to emphasize the fact that you probably shouldn't be doing that there are better alternatives out in the world. We also have Mason's second law, which is be careful moving things straight to adopt. That's kind of a smell. Some brand new technology that you're saying is a total no-brainer. You'd have to think twice and 3 times before we would actually move something directly to adopt. It's not unheard of, but it's really, really rare. And hold items are almost never just for spite. We almost are always there to suggest an alternative, not just to say bad things about technology. Questions about any of these rings before we move on? So if you decide to build one of these radars yourself, I'm still talking about mechanics here, I wanted to point you to the hard part has already been done for you. One of my colleagues, who clearly has too much free time in his hands, it's a little hard to see on this screen, has actually built this radar view for you and open sourced it on GitHub. All you do is fill in a JSON data structure and it draws this radar for you on an HTML5 canvas using JavaScript. So that's all you have to do, fill in that JSON data structure and everything else is good to go. This is the JSON data structure that he created for it. Never let it be said that one of my colleagues couldn't over-engineer something slightly. He wanted to have exact placement within the ring, so all the coordinates in this JSON data structure are in polar coordinates, which gives you exact placement within the rings, but a little bit of a hassle to put in there because you have to figure out what they are in polar coordinates. And in fact, he has much more exact placement. We don't really fret about the exact placement within the ring. We will sometimes try to make a statement by saying something's moved a little closer, but frankly, the spacing within the rings for us is more about getting the labels to all fit than it is anything else. So we're not trying to make a statement, we're just trying to get them all fit most of the time. He actually gives you the opportunity to directly affect where things go. And we're actually going to use this to build an interactive version of our radar where we kind of scroll backwards and forwards in history and see movement of these blips on our radar. So that's the ThoughtWorks radar. Then a kind of a weird thing happened. So we started producing the ThoughtWorks technology radar in 2010, I believe, maybe a year earlier than that. Yeah, it was probably 2009. And I started having people come to me at conferences. I wasn't doing this talk, I hadn't even thought about this talk, who were saying that they'd started using this radar for their own purposes. And it got us started thinking about, this is actually a pretty good metaphor for a couple of other things. And I'm going to talk about those things. And the first one I'm going to talk about is building a developer radar for yourself. And this requires a tad more history about me. Back before I joined ThoughtWorks, I was the CTO of a small training consulting company. Whoops, went too fast there. Small training consulting company that did Clipper development on DOS. Anybody here ever heard of Clipper? You realize you're dating yourself if you say you've heard of Clipper, because it's an old technology. But everything was fantastic in the Clipper world. We had 25 people working for the company. We had a good sales pipeline. We were doing training consulting on Clipper. Everything looked fantastic. And then slam, Windows came along and just destroyed the Clipper market entirely. And as the CTO, I got really blindsided by this. It made me realize in a big way that whether you like it or not, technology marches on. And if you're involved in a particular technology, you are living in a technology bubble. And when that bubble starts contracting, you can't tell from the inside. And that's a really dangerous place to be, because when that bubble starts contracting, that means the jobs in that technology are going to start contracting. And sometimes you don't realize it until they're all gone. And it really blindsided us. It made me realize that you really have to manage your knowledge portfolio much like you would manage a financial portfolio. Don't put all your eggs in one basket. Diversify somewhat and make sure that you know what your next technological direction is going to be from a job standpoint. Don't just get distracted by the next shiny thing that's coming along. Be sure to be more strategic about choosing technologies. And that's what this technology radar is really useful for, is an exercise of sitting down and thinking about what is the intersection between my interests and things that I think are going to be really popular in the technology world over the next few years and over the next few decades. Because a lot of people for their career think very tactically but not very strategically. And what I'm trying to get you to do is think more strategically about this. When you create a radar for yourself, I would suggest using the same quadrants that we have, because this partitions the technology world pretty nicely. Techniques include things like agile development and test-driven development and continuous delivery. Tools are things like IDEs and databases. Platforms are things like Java and .NET, Ruby. JavaScript is a platform. Languages are, of course, computer languages, JavaScript, etc. But here's a problem when you start trying to choose technologies. Let's say that you're involved in the Java space, just kind of arbitrarily. You could actually do this with any technology. Let's say that all development in the Java ecosystem stopped today and there was none other done forever. You could easily spend the rest of your life looking at just the stuff that's there right now. What that suggests is you need really good filtering mechanisms to choose technologies. These are things that I'm calling litmus tests. Tests that you can apply to technologies when you first encounter them to help you decide, should I spend more time looking at this, or should I go look at something better for my career or better for my personal development? I'm going to give you some litmus tests that I use, but I don't want to suggest that these should be yours. These are highly personalized. These have to do with things like how you learn, how much you like new things, how much you hate new things, how quickly you learn things, and a bunch of other factors like that. But I'll give you some of my litmus tests that have been very successful for me in the past. And a big one for me is testability. If I can't do good testing in a piece of technology, that means I can't do proper engineering practices. I'm not that interested in that technology. So for example, Flex is a good example of this. When Flex first came out, I looked at it, and I looked at the testing story, and the testing story was really anemic. And that was good for me, because I could say, okay, I don't need to look at Flex at all until its testing story gets a lot better. It ended up dying before its testing story got better, which is good. I never wasted 1 minute on Flex. And now that's a dying technology, and I never have to worry about that again. So testability is really good because so many tools fail this. And yet, it's so important to do good engineering practices to have things that you can easily write tests for. Integratability is also a big deal. No matter how cool something is, if you can't get it to work with all the other stuff you already have, then it's not going to be a very good bargain. So you may have a really a strict Java shop, and you may dearly love F#, for example, the .NET world, but you're never going to get your company to take on a brand new platform just so they can use one language like that. So integrability is very important as well. Learnability is also really super important, particularly for very complex things. So for example, if you're embarking on learning something relatively complex like Scala, you might want to put together a study group. You'll actually accelerate your learning a lot if you can do that. The other nice thing about learnability is try to figure out things you can learn as part of your day job. Because whether you realize it or not, when you signed up as a career for a technologist, you also signed up for a lifelong course in continuous education. You are, after all, sitting in an almost windowless conference room on a weekday carrying out that part of your career. You always want to keep doing that, but you want to find ways to do that most effectively. So a really great example of this is, let's say that you're in a Java shop, and it's a very strictly Java shop, nothing crazy like Groovy ever goes into production, but a lot of times there are a lot looser rules for developer tools. So maybe start writing all your unit tests in Groovy or Scala. None of that code ever makes it into production. It's a single jar file. It's just a utility that you're using. And it actually speeds up your ability to do testing, so you actually speed up your development process and improve your engineering practice at the same time. And you get to learn a more modern, higher level language as part of your day job and not steal time away from your family. That's a really important way. If you can find some combination like that, that's a really, really useful thing. You can also look at external references. Conferences are great places to assess new technologies for you so that you don't have to go through that assessment phase. You can also find really good authors, and I point out this book in particular. This is a very old Java book. In fact, if you look at the publication date, it's quite amazing. This is almost 900 pages, and it was published in July of 1996. This is the first ever advanced Java book, and it was published less than a year after Java itself came out. Glenn Vandenberg had a magic crystal ball, because it was not a foregone conclusion when Java came out that it would become a popular technology, but Glenn saw something of great promise there, enough to invest all this time into writing this book. So you have to ask yourself the question, does Glenn's crystal ball still work? And I happen to know Glenn, which is why I brought this particular picture up. He is currently splitting his time between Ruby and Clojure, which are his two language passions right now. Another great prognosticator of technologies is Bruce Tate, who is a really amazingly good at picking brand new technologies. This is similar to the way that I do movie critics. I try to find movie critics that have the same opinion about movies that I do. And once I've found them, when a new movie comes out, I go look at that review, figuring they have similar opinions to mine. They'll probably be pretty accurate. Find some technologists who like the same kind of technologies you do and like the same aspects of technologies you do, and look at the things that they're assessing and look at the things that they're pursuing, and maybe that'll give you some direction of the things that you should be pursuing. You can also go to external sources to find out useful information, but you have to be careful about where their data comes from. So a great example of this is the TIOBE popularity scale for computer languages. So TIOBE publishes this chart. If you look at it, you might think that this is a pretty good representation of language popularity. But then you have to ask yourself, where do they get their data for this? Well, they get their data just by slurping news groups. So if I've just come out with a new version of RPG for the OS 400 and it's the worst release ever on RPG for the OS 400, the news groups are going to light up about how terrible it is, and it's going to rise in popularity on the TIOBE index. Because TIOBE doesn't care if people are saying good or bad things about it, it just cares that people are talking about it. And I think that's why there's still a fair amount of C and C++ development going on in the world, but I think it's so high on the TIOBE index because the news groups are always lit up with, why is my stupid C program not working? So that always artificially inflates it because there's a lot of confusion in that space because it's such a complex thing. So it's good to look at external sources, just make sure you understand where their data comes from. Another one of my favorite litmus tests is narrow suitability to task. Commercial tools in particular try to overload them with features so that they look good against other products. But I actually like things that are very narrowly suited rather than big comprehensive things. In fact, that leads really nicely into this idea of how do you choose a technology? What are some guidelines for choosing a technology? How do you make that choice? Well, for me, this narrow suitability to task is really, really important. And in fact, you see this playing out in the world right now. In the software world, we keep going through these pendulum swing from one trend to the other. The big pendulum swing we're seeing right now is in the JavaScript world. Because in the early days of JavaScript, it was the big, giant, comprehensive libraries like jQuery And now you're seeing all these little tiny micro frameworks where you mix and match all these little tiny JavaScript frameworks to get stuff done rather than having one or two big giant ones. You see this with web frameworks. We have the Ruby on Rails and Grails, the big full feature does everything web frameworks. And then you have the very simple routing based frameworks like Sinatra or Ratpack or Clojure or Composure or one of those. You see this kind of dichotomy out in the world of simple mix and match tools versus big tools that try to be comprehensive. I tend to like simple mix and match tools better so you can get kind of best of breed kind of tools. And really this gets down to understanding current trends in the technology world. The big trend right now is to do single page model view controller, model MVVM JavaScript applications. And so that's a big trend in the technology world right now. So looking at technologies around that trend looks like a pretty promising place. The other thing you want to do as you evaluate technologies is to normalize feature sets between technologies. Every open source website in the world talks about all the fantastic things that this open source framework will do for you, and none of them ever tell you about all the horrible things this open source web framework will do to you. Because they're trying to get you to try it. So anytime you're evaluating technologies, try to normalize the feature sets. Every commercial product comes with a feature matrix, which are all the features that it supports. Think about building your own feature matrix for technology that you're assessing against one another. Think about the things that you want and the things that you don't want, and make sure that you know the answer for each technology. Because what you'll find is, just by poking around out in the world, you'll have an incomplete feature matrix because there'll be some things that the website just won't talk about because this framework doesn't do it particularly well, but it's something that you need. So your feature matrix should include the good, the bad, and the ugly for each one of your choices, and this gives you a more apples to apples way to compare those different technologies. You also need to avoid what I call in the technology world the suck-rock dichotomy. I wrote a blog post about this a while ago. It's basically this tendency in the software world to say everything either rocks or sucks, and there's no middle ground between those things. I think that's because it takes a non-trivial effort to learn technology. It takes a year or two to really learn technology. And the last thing you want is somebody to come along and say, oh, you learned that technology. Well, that was a big mistake. You should have learned this other one. Your knee-jerk reaction is to say, oh, yeah, well, I rock and you suck. But that doesn't make a very good conversation. So you have to be careful when you're talking about technologies. Don't fall into the suck-rock dichotomy and try to make sure that you understand the real benefits or downsides. Another great way to avoid these kind of problems is to do these spikes. This is the time box experimental coding exercises, very popular in the Agile world. This is purely just knowledge gathering. This is a way that you can move things from assess to trial if you really want to see what's going on, or to fill in a part of a feature matrix that the website doesn't say anything about what it does in this particular case, so let's build a little thing and see what it does so we can fill out and flesh out our knowledge about what this thing does. Purely about knowledge acquisition. This is not a prototype. This does not grow into real code. It's just meant to be throwaway code. It's typically developed, in fact, on a dead-end branch in your version control. This is just about learning something about that technology. So when you build your radar, one of the things that's worth thinking about is this kind of safe no-brainer versus far-out technology choices. Your far-out technology choices, who knows what that's going to be. That's more driven by passion or interest than anything else. But there are a couple of pretty obvious kind of no-brainer technology choices in the world right now. Pretty much anything with Spring and Java and Hibernate is a pretty safe bet right now. That is the COBOL of the new millennium, meaning that's the way business applications are written now, so that's going to be safe for a long time. But it may not be the most exciting space to be in. So there's one of those trade-offs. Do I take the safe known path, or I go a little riskier and maybe launch into the JavaScript and Node space, and it's maybe more exciting and more frontier, but a little riskier as well? That's part of the assessment and trade-off you need to make. Another really active technology space right now is anything around HTML5, JavaScript, CSS. There's a huge rewrite of all these old web technologies like Flash, et cetera, being replaced by newer JavaScript technologies. So there's a lot of activity in that space right now. So building a developer radar, in some ways, I think is almost a no-brainer. This is just a career development plan. This helps you manage your knowledge portfolio, kind of the way you'd manage a financial portfolio. lets you proactively guard your career. This is a pretty good exercise to do once a year or so. In fact, once you do this once a year, start keeping these year after year, because one of the things that you want to get better at is predicting the future. And by going through this exercise once a year or so, you force yourself to think about what the near future is going to be, and then a year later you can see how well you did and then feed that into the next radar you build. After 2 or 3 years, you'll find that you're getting a little better at being able to predict the things that are moving and the things that are kind of stagnating. So this one I think is kind of a no-brainer. The third one, though, actually came as a big surprise to us. Because we had several people come to us and say, you know, we did one of these radars as an internal company exercise, the best thing we ever did. And we've now started recommending this to a bunch of our clients and have come up with a bunch of reasons why you want to do this for your company. I actually have 6 reasons for why you want to do this. This also gets to where that radar metaphor came from, by the way. So you're all familiar with the Gartner adoption curve of technologies. For any kind of technology, you have a small group of people who are innovators, then you have early adopters, then you have the early majority, then you have the late majority, and then you have the laggards. But notice that for any particular technology, there's a perfect place for your company to be on this curve that balances risk versus adoption rate. So let's say that you are a financial services company based in Manhattan. You care a lot about high performance concurrency, and so you maybe want to be an innovator on Scala and Akka and Clojure because those give you those kind of technologies. But you don't really care about big data. You don't have any big data, so you could easily be a laggard on big data. That's not important to you from a technology standpoint. But maybe your insurance company, you care a lot about big data. You don't care anything about concurrency. The point of this is, for your company and a given technology, there's a perfect balance between risk and a reward for you to be on this curve. Here's the problem trying to capture all your technologies together is that you don't have just one technology. You have hundreds or thousands of them. Every open source framework you have is a technology, every commercial product you have is a technology, every language, every database. So how do you capture this feel for a whole bunch of different technologies? This helps you balance risk versus reward. So if you take all those curves and kind of overlay them on top of our radar categories, and then drop a snapshot in time through them, and then kind of take this and rotate it up 90 degrees, you have a radar view. That's where this radar metaphor came from. What we're trying to do is take a slice. You can think of the Gartner adoption curves for all your technologies moving down a tube through time. We just sliced the tube like a tree trunk, and that's where all these guys are on their Gartner adoption curve at this snapshot in time. This is where this radar metaphor came from. How do you capture where you should be on the Gartner curve for all your technologies as a snapshot in time? So what this lets you do over time is helps you balance risk versus adoption rate. Once you started doing this, it actually becomes a platform for doing continual analysis in this space. Because just like as an individual, you get better and better the more radars you do, as a company, you get better and better at predicting the future the more of these radars you do. You now have a standard format to capture this information in. So here's another reason. Let's say you're in a company where the decision makers live in an ivory tower, whether it's a CTO or it's a small group of architects or the decision makers for technology are disconnected from the day-to-dayness from developers. I'm modeling this person as a stick figure with a tie. And so every once in a while, the stick figure with a tie will walk around and talk to people who actually touch technology all the time. And so he'll come say, hi, Bob, and say he's really excited about some random thing he just read about. Talks to somebody else, and they're having problems with Maven. Okay, that's really tough. He goes and chats with somebody else, and he says, hey, can I go to the Black Hat Con this year? Can you give me budget to go do that? It's like, well, okay, we'll see about that. He goes and finds another group by the water cooler, and they're talking about their bills being slow. Well, he's post-technical. He doesn't realize that these are actually related to the same thing. But when he ascends back up into his ivory tower, his impression is that, wow, developers complain a lot. And they have weirdly misdirected passions. The things that they care a lot about, they're not that important to me, but the things that are really important to me, they don't seem like they care that much about. But here's what never happens in most big organizations. Never does that decision maker gather all the people together who have been affected by their decisions and ask them, hey, did I do a good job or not? Because almost universally, bosses hate it when their employees call them stupid. And so they'll almost never give you the opportunity to do that. This is a broken feedback loop in most companies because the people who touch technologies are not the people who make decisions about technologies, and there's no feedback loop to let the decision makers know that they're making horrible decisions. Or maybe there is, and they're just willfully ignoring those because they like the free golf outings to Scotland that they're getting from some hideous tool vendor somewhere. But this helps you shore that up. You need a forum for unified communication from this group, and that's exactly what this radar becomes. When you do this as a group within a company, what you've created is an objective feedback loop back up to the decision makers, not with name calling or anything like that, but as a valid assessment of this is what we think our technology is doing, and it comes directly from the practitioners of the technology, not the people who are detached from it. This is a really valuable thing for your company to have. If you don't have this feedback loop in place, this is a pretty good way to establish it. The fourth reason is that a lot of companies have disparate groups of technologists. So you'll have some Java developers here and some .NET developers over there and some PHP over here and some Ruby on Rails over there. And while if you're a Java developer, you probably hang out with the other Java developers all the time, you probably never talk to the PHP developers. But you should, because you have more in common than you think. So this becomes a great forum to get together. I'm actually going to talk about this, sorry. This becomes a great forum to get together and plan things as a group. Go here. It's a great excuse to get together and have impassioned conversations about technologies. And let me show you how this works. I had a friend that works for a big insurance company in the US, and the developer group had been trying to get Ruby approved for almost 2 years because they wanted to do some Rails stuff. But the policy at this company is no single department gets a one-off technology. You have to have at least 2 departments that want a technology before we'll approve it. Well, they got together and did a technology radar, and there's another group of developers over in the marketing division that are doing PHP development that wanted to use Cucumber to write their tests in, and Cucumber requires Ruby. So putting together this radar made the decision makers realize, oh, more than one person wants this, 2 weeks later, approved. They've been trying as technologists for almost 2 years to get it approved. The exercise of doing this across disciplines within the company showed that there was a groundswell of support for it, and so it was approved almost right away. The last 2 reasons, obviously you want your business view and your IT view on technology to align. And most of the time they do. What if your business merges with a company that has really dysfunctional technology? These 2 things can diverge from one another. This helps you align the business and IT views on technology. So ultimately this becomes a really valuable decision-making tool from the CTO because now he has a richer stream of information about the decisions he's making than he had before. When doing a company radar, I typically change the quadrants a little bit. I still leave techniques, tools, platforms in place, but languages are so often not talked about in big enterprises that I tend to move those up into tools and talk about package and commercial off-the-shelf software here. But you know, CTOs have litmus tests as well, and often their litmus tests look a lot different than the ones that developers put together. So for example, a litmus test for a CTO might be licensing and cost. Every technology has a cost associated with it, even open source technologies, because you have to worry about training, downtime while people learn the new technology, and conferences and all those other sorts of things. So even free things have a cost to a CTO. A lot of CTOs are also worried about what's going to cost them their job, and so they make technology choices based around kind of the herd mentality of the industry rather than the technological constraints and opportunities in their organization. This is something that the CTO really should be looking for, is competitive blindside. I don't think enough CTOs look at this. When you start looking at the way that continuous delivery is changing the way big companies do software development, you're asking to get blindsided here. A good example of this is we had a client, so in the continuous delivery world, cycle time is the amount of time when you start working on a new feature, it shows up in working software. We recently had a client who had a cycle time of 6 weeks. We reduced that to 2.5 hours. If their competitors are still on a 6-week cycle time, I can come out with 500 releases for every one of your release. That's got to be an advantage for me. I can move so much faster than you. I can spin rings around you in the amount of time you can make changes to things. In fact, there's a great story behind this that Paul Graham tells in Hackers and Painters of the very first build your own e-commerce website that he built. He built it in Lisp, which is a very controversial decision at the time, but he built it all as these DSLs in Lisp, and because he was working at such a high level of abstraction, all of his competitors were working in C and Perl and languages like that. So anytime they made a change, it would take their competitors weeks to make the same change. Anytime their competitor made a change, they could implement that in just a few days. But Paul Graham said that when he was CTO of that company, he always looked at his competitors' want ads. If they were hiring C and Perl developers, he didn't worry about them. If they were hiring Python, he kept an eye on them. He said, if anybody had been hiring Lisp, I would have flown into a blind panic, because that means they would have technological abilities equal to mine, and now I'm going to have to start competing with them on a business standpoint, not on a technology standpoint, because they had a huge technology advantage. I'd rather compete from here to here than in equal grounds. So Paul Graham sold via web, and it became Yahoo Stores. There's a tragic epilogue to this story. When Yahoo purchased it, they looked at all that Lisp code and didn't understand it, so they threw it away and rewrote it in C. The advantage that they had paid their millions of dollars for, their technologists didn't understand it when they saw it. He calls this the blub paradox, that when you look at more powerful languages, it just looks different, but you don't realize that it's more powerful. And so they purchased it for this advantage and then immediately tore the advantage down and tore themselves down to being equal to their competitors, which is a terrible technology decision. That, I think, goes on the head of the CTO when that happens. Last thing I'll talk about is package a commercial off-the-shelf software, which is unique to enterprises. Make sure you verify everything the vendor says. They are more interested, their salespeople are more interested to talk about feature matrices and things like that than actual features. It is not at all uncommon for things that are checked off on the feature matrix to not actually work. It's going to work in, service pack 2 or 3 later or something like that. Have a geek look at the contract. A lot of times we have clients who have signed kind of sketchy deals where they were promised something, that wasn't delivered, but you can pay them now to get this, but then they retain ownership of the extensions you build for them and stuff like that. Yes? Oh, sorry, commercial off-the-shelf software. Commercial off-the-shelf software. COTS, it's like package software. Enterprise software, like Oracle Financials is COTS, Lawson, HR, any ERP package is COTS, it's package software. Enterprise package software. Negotiate licenses. These are always sold by licenses, but if you want to do some sort of engineering best practice like continuous delivery, very often they will negotiate licenses for you. And measure technical debt on these tools. Any feature that you're buying that you're not using right now actually just manifests as technical debt. So be careful that you don't overbuy tools, because a lot of times you're buying more technical debt than you are actual capabilities. The other thing that's worth noting here is that the radar for a CTO is a very different place. It's a lot less risky than it is for developers. And in fact, there are 2 things that I think is on every CTO's short list of things that I'm worried to death about right now. One of them is mobile. Nobody wants to build 4 or 5 of the same thing. And users have spoken loud and clear, if you don't use every stinking feature on this phone, I'm going to give you a 1-star review. So you've got to go native. People hate cross-platform applications. So if you're trying to sell this out into the world, it's got to be native, but here's a big problem. Got to have an HTML version, got to have an iPhone version, got to have an Android version. BlackBerry, it's getting a little sketchy now. Windows Phone, that's even less market share. Do you really want to invest in that much market share when you've got to split your time? And you can share virtually none of the code between these platforms because you have Objective-C and HTML and Java Lite in the Android world and Windows. So you've got all these disparate platforms. None of the cross-platform stuff works well yet, so this is a really terrible decision point for CTOs right now. The other thing that's causing them sleep is cloud. How am I going to incorporate cloud? If you wait too long, then you're too late. If you go too early, you're too early and you take too much risk. So the CTO has very different kinds of things that they worry about than regular developers do. So building a company radar, try to do small groups, less than 30 people, and aggregate the results together. All interested technologists get to participate. There shouldn't be just the senior people. It should be everybody. Actually do the little write-ups. Those are very valuable a year from now when you're trying to figure out, now, why did we put this in trial versus assess? Revisit it regularly. I would say at least once a year. Some of our clients are actually doing this twice a year now because they're in fast-moving technology spaces. And make sure that you actually take advantage of the results and do something with it. So building a radar, the exercise is more important than the artifact. It's strategy over tactics. Try to keep your eye on information from weak social links. These are the other developers in your organization, the people that you don't necessarily see every day of your life. A lot of times the really interesting things are going to come from those kind of weak social links that you don't see every day. Try to keep an open mind about technology across technology groups. Try to avoid the suck-rock dichotomy and do this often. It's also worthwhile doing both exercises because once you do it for yourself and for your company, it allows you to do a delta between the two of them and decide, is the company I'm working for moving in the same direction I want to move my career in? Because notice, a radar can be a defensive tool, but it can also be an offensive weapon. You may use this and realize the company I'm working for is not going in the direction I want to go from a technology standpoint. Maybe it's time to start searching for another company. And I don't think this is ever going to happen, but this is a nice metaphor so I can dream. I would love for the day to come that when you come and do a job interview for a new company, you say, here's my technology radar, let me see yours so that we can see how well these two things line up to see if I'm going to be a good employee for you or not. And I don't think that's happening yet, but I would love to see that happen. So a little bit over time, and I realize that I'm now chewing into lunch, and I know better than to keep talking when lunch is being offered. If you have any questions about this, I'll be happy to answer it today or tomorrow. Do you have a question? Quick one.
Yes. At one part of your presentation, I remember you were speaking about continuous evaluation of the technology, building a continuous radar.
Yes. So the question